of which have been within the state of Mississippi, but also in Louisiana and Tennessee, Florida, North Carolina, Montana, and some federal trials as well.
Matter of fact, you've been accepted as an expert right here in this courtroom, have you not?
Yes, I have.
Your Honor, I would offer Ms. Rogers as an expert as a forensic analyst specializing in DNA.
All right. Does the defense wish to voir dire Ms. Rogers on her qualifications?
No, sir, Your Honor.
All right, so the court will accept Ms. Rogers as an expert in the field so offered. You may continue.
Ms. Rogers, I know a little bit about it, but the jurors don't. Would you kind of explain to them what exactly is DNA?
Sure. So DNA stands for deoxyribonucleic acid. But what it really is a long molecule that's packaged into chromosomes that contains all of our genetic information. Excuse me. In forensic DNA testing, the type of DNA that we target is known as nuclear DNA because it resides within the nucleus of the cell. There's trillions of cells that contain a nucleus within our bodies. Every cell except red blood cells has a nucleus. So it's these cells that we are looking for when we're examining evidence for forensic casework. So those cells could be shed just by simply touching or having contact with an item, or they also can be carried in biological fluids such as blood, semen, saliva, sweat. All of those fluids have the potential for carrying cells within them. So it's those things that we're typically tasked with looking for when examining items of evidence. And the DNA that we target goes through a stepwise process each time to try and purify that DNA and get enough of it to observe. And then finally, we hope to develop DNA profiles from the evidence that we examine.
And would somebody like me have a lot more than 1 trillion cells?
Well, you know, the more, you know, everyone's body carries trillions of cells, and I guess potentially the more mass, the more cells.
That's what I thought. You mentioned a moment ago skin cells. I believe you said that. And if you touch something, you might leave a skin cell, something of that nature. And I guess what I'm trying to get at is it possible through a skin cell I could have left some DNA right on this podium just then?
Yes. So whenever a contact is made, there's the potential to leave behind some cells. And therefore, if there are enough cells and those cells are of good enough, you know, quality, there's the potential to process a DNA profile from those cells left behind.
And it only takes one cell to be able to at least get a partial or a full DNA profile. Is that correct?
Technically, yes. We should, in theory, be able to get a DNA profile even from one cell, because one of the steps of that process that I described briefly is called amplification. And so even one cell can be copied through that amplification process, and we make copy after copy after copy of whatever DNA was there initially. And hopefully at the end of that amplification process, that would allow us to have enough DNA to visualize as a profile.
Would you explain to the jury, please, what technology you use? Actually, I'll go back to 2014. What technology you were using, or early 2015, what technology you were using at that time to be able to attempt to get some kind of a DNA profile off of a sample that is submitted to you?
So yes, so samples that are submitted, again, after we do a screening process, we are doing what's known as STR analysis, and that stands for short tandem repeats. And what we're doing is when we amplify that DNA that hopefully we have picked up through processing an item, we're targeting specific areas of the DNA molecule. Those specific areas are then put together to generate a person's DNA profile. When we do what's known as autosomal DNA testing, we're targeting 16 of those areas that are spread throughout the chromosomes. And if we are successful, for example, a person's known or reference DNA sample will typically give us a full DNA profile. and each individual's known DNA profile has a frequency of less than 1 in 999 trillion. So if we're successful in getting a single source full profile from an item of evidence, we can say that that profile is unique to an individual. So it's those 16 specific areas that are targeted when we attempt to get a DNA profile. Sometimes, however, we may only get a partial DNA profile if there's only very little amount of DNA there initially, or if the DNA is somewhat degraded or damaged, we may only get a partial profile. We can also get what's known as a mixture, which is multiple people's DNA combined together into a mixture, which we have to interpret a little differently. Or, of course, sometimes we get no DNA profile at all.
Well, let's go to this particular case. I want to hand you what's been previously marked as exhibit number 2. And I would ask you to look at that, please, and tell me if you can identify that.
Yes, this was an item of evidence that was received by the laboratory for testing in this case. The description is keys, keychains, and rope and tags. We have our Scales Biological Laboratory case number sticker still is present on this item. And then we assign an individual specimen number to each item that we process for DNA. That number is still here, as well as the evidence tape that I initialed and dated after processing this item is still present.
And is this the item that you were asked to process?
Yes, it is.
I think these have been previously identified as Jessica Chambers' keys.
For the record, what's that exhibit number, Mr. Chairman?
Number 2.
Thank
Yes,
you.
sir. Ms. Rogers, once you receive that particular piece of evidence, what is the first step that you would take in an attempt to obtain a DNA profile off of the keys?
So on this particular item, the goal was to try and obtain any DNA that may be present on that item as a whole. In order to do that, I swabbed that entire item, the lanyard that the keys were on, each little keychain that was there, the key itself was all swabbed using a sterile cotton swab, and that's done to hopefully pick up any cellular material that may be there, cells, of course, containing the DNA. So that item was swabbed in its entirety and then put through that stepwise DNA process, which involves purifying the DNA, which is essentially, extracting DNA from the cells, getting the DNA out of the nucleus of the cell, and then purifying that, hopefully getting rid of all the other cell components or things on that particular sample that we're not looking for. And then we amplify it, as I mentioned, which is the stepwise process of making copy after copy after copy. So any DNA that's there initially will be copied through that amplification process. And then at the end, we analyze the item and look for any DNA that might be on there in the form of a DNA profile.
You mentioned earlier that if you were able to get a solo cell, I'm probably butchering the way I'm trying to say this, but you mentioned a minute ago that there are 16 loci. Is that what you call them that you look for?
Loci.
Loci
Yes.
that you look for. And do you get that on every single piece of evidence that you receive? Are you able to actually obtain a full DNA profile on every case that is submitted to you?
No, certainly not. We do attempt to do that on every item. We target those same 16 loci, and loci is just another word for location on the chromosome. It's the 16 fragments of DNA that we examine to attempt to get a DNA profile. So we attempt to get a profile at those 16 locations on every item. But as I mentioned, sometimes we get no profile at all, no DNA detected at all. Sometimes it's just a partial, meaning that we got an answer or we observed DNA at some of those locations, but not at all of them. And sometimes we get a mixture of DNA, meaning multiple people's DNA is detected at those locations.
And I think you just said a mixture. Is it uncommon that you get an item of evidence such as keys that would have a mixture of DNA on it?
Well, as I often say, like there's really no normal in forensics. We do typically get mixtures on a lot of different items of evidence. I hate to use the word normal because we see all ends of the spectrum. Like I said, sometimes no DNA, sometimes a single source, sometimes a partial, sometimes a mixture. But it is not at all uncommon for us to get a mixture on items, especially those that may have, just by the nature of the item, may have been handled or used by multiple people.
And in this particular case, what type of profile were you able to generate from these keys?
It was a mixture of DNA, a mixture involving multiple people.
Okay. Now, you had submitted to you DNA samples from Derek Holmes, Jerry King, Lakeisha Meyer, Quinton Tellis, Rachel Mister, George Douglas Mister, Roscoe Spates. Is that correct?
That's correct.
And when you performed the DNA testing on this, you said you got a mixture. Is that correct?
Correct.
And I would go, well, let me read this. I'm going to hand you a report that was generated December 14th, 2015. Do you recognize that?
Yes, this is the report that I generated for this case.
John, I'm off. This is an exhibit. This witness testimony.
Any objection? All right, being no objection, be marked in admitted. Once you get it marked, pass it to the court, please.
Number 36.
Ms. Rogers, do you have a copy of this?
I do, yes.
I'm going to keep this right over here.
What's that exhibit number?
36.
36.
Now, I believe you had some various pieces of evidence that were submitted to you in addition to the keys. Is that correct?
Yes, it is.
I believe you had a Bud Light bottle or blunt wrappers. Is that correct?
Yes, it was actually 2 Bud Light bottles and some wrappers, correct.
And were you able to obtain any kind of a DNA profile off of them?
Only from one of the Bud Light bottles, the other Bud Light bottle and the wrappers, there was no DNA profile obtained.
Okay. And I want to go down to conclusion number 2. When you say a mixed autosomal STR DNA profile, what do you mean?
So the autosomal profile refers to the chromosomal locations that we targeted. As I mentioned before, there are 16 locations that we target. Those are on the autosomal chromosomes, which means those are the chromosomes that everyone has. There is a chromosome that's unique to males that I'll talk about in another conclusion, the Y chromosome. But autosomal chromosomes are the pairs of chromosomes that our DNA is packaged into that everyone has. We all have 23 pairs of autosomal chromosomes.
And how many individuals did you obtain, or how many individuals are in the mixture that you found on the keys?
So the autosomal mixture from the keys and the keychains and the lanyard did give a mixture of at least 4 individuals.
Okay. And Quinton Tellis was not one of those on the autosomal, is that correct?
Correct. Through the autosomal testing, that autosomal mixture, he was excluded from that.
Okay. And so was Derek Holmes,
Correct.
Jerry Lee King,
Yes.
Lakeisha Meyer,
Yes.
George Douglas Mister Jr.,
Yes.
Roscoe Spates,
Yes.
Anna King,
Yes.
and Mary Tyner
Correct.
are excluded, but Jessica Chambers was included as a possible source of the autosomal mixture. Is that correct?
That's right. She was included in that mixture.
Okay. Then number 3 is the DNA you said you found on the Bud Light bottle. And it did not match Jessica, Derek Holmes, Jerry Lee King, Lakeisha Meyer, George Mister, Roscoe Spates, Anna King, Mary Tyner, or Quinton Tellis.
Correct. They were all excluded from that Bud Light bottle profile.
Okay. Now I want to go down to conclusion number 4, and you mentioned a mixed Y-STR DNA profile. And what do you mean by that?
So this was a second type of DNA testing that I performed on that set of keys. So initially, as we just discussed, I got that autosomal mixture of at least 4 individuals. So males or females together, there was male DNA seen and female DNA seen. How we can tell if it's male or female is through the X and Y chromosome. So we do target the X and Y chromosome in our analysis. On that initial testing of the keys, the X chromosome was significant, and the Y chromosome, indicating male DNA, because males only have Y chromosomes, only males have Y chromosomes, that Y chromosome was tiny. So that makes it a good candidate for this Y chromosome analysis. And this type of DNA testing is a little different because it targets DNA not on all the autosomal chromosomes, but only on the Y chromosome. So it's only targeting male DNA. So it's ignoring all the other DNA that might be on those keys, and it's targeting just males to perhaps get a better idea of the male profiles that are included in that mixture. So this Y-STR analysis was also performed on those keys.
Okay. And once you perform, and I'm trying to simplify it for my purposes, you found a Y chromosome in the mixture of the DNA, is that correct?
Yes, the autosomal mixture indicated that there was some Y chromosome DNA in there, some male DNA, but it was significantly less in proportion to the X chromosome that was present.
Okay. So there was less male DNA than there was female DNA?
Correct.
Okay. So what was your conclusion concerning Quinton Tellis when you performed the Y male-only STR DNA testing?
So that Y-STR analysis, which again just targets Y chromosome DNA, which typically only males have a Y chromosome, still gave a mixture of at least 4 males. However, Quinton Tellis could not be excluded as a potential contributor to that Y-STR mixture. In addition, all of his patrilineal male relatives cannot be excluded. And the reason for that is all males in the same paternal line should have the same Y chromosome profile. So he nor his patrilineal relatives could be excluded.
All right, let's stop there just a minute. Okay. Quinton cannot be excluded. Is that what you're saying?
Correct.
and neither can any males in his line, patrilineal line. Is that correct?
Yes, his paternally related males, males on his biological father's side.
Okay. And all right, continue with your conclusion on that.
So yes, so and also when we get a mixture on this Y-STR analysis, we have to calculate the frequency of males that could also have that same Y chromosome profile. So approximately 99.7% of the male population would be excluded as being a contributor to this mixed STR profile. And that particular STR profile has a frequency of 1 in 359 males.
Within his patrilineal line, is that correct?
And in the general male population as well.
Okay. Now, at what conclusion did you reach? Could you reach a conclusion as to Jerry King?
No conclusion could be drawn regarding Jerry King as a contributor to that Y-STR mixture. When we're doing these comparisons, so we get a Y chromosome profile from each of these individual males as their reference profile and compare it to that mixture that was found on the keys. Mr. King did have some consistencies with that mixture, but not enough to reach a firm conclusion. So it was inconclusive whether or not Jerry King could be included or excluded on that mixture.
Okay. And what about Derek Holmes?
He was excluded from the mixture.
Okay. Attend to the witness, Your Honor.
Cross?
Good morning, Ms. Scales.
Good morning.
I'm going to try my best here, okay?
Sure.
I got an A in PE, but biology, terrible. On basically, like you were saying, our bodies are made up of cells, lots of cells, correct?
Correct.
Okay. And in the middle of a cell would be the nucleus.
That's right.
And in the nucleus is where our DNA is located in the chromosomes, correct?
Yes, this DNA that we're examining. That's
Okay.
correct. Mhm.
Okay. And so as far as autosomes, is that on the chromosome?
That refers to the chromosomes themselves.
Okay.
Our 23 pairs of chromosomes are our autosomal chromosomes. And then, I'm sorry, it's actually the 22 pairs. And then there's one remaining pair that's our sex chromosomes, our X and our Y.
Okay. So the 22 pairs that are in our cell, which is 44 individual chromosomes, right?
Correct.
Okay. And those are more particular to us as individuals.
It depends on the regions that are targeted. The 16 locations that we target have the potential for being, highly polymorphic between individuals. They change a lot between individuals, but it depends on the area. There are some chromosomes that don't vary very much, some areas of the chromosomes that don't vary much between individuals. But the 16 areas that have been developed as those areas that we target for DNA testing are highly individual.
Okay. So the 16 are highly individual to each person for the most part.
Correct.
Okay. And the other two that you spoke about, males would have X and Y, and then females just have X, correct?
Right. Females have two X chromosomes, males have an X and a Y, correct.
Okay. So in this instance, in targeting the 16, I guess, of the 22 autosomal,
Yes.
you came up with, you targeted certain, well, let me rephrase it this way. You got buccal swabs from different individuals, correct?
Yes, for the reference samples. Mhm.
Yes. And as Mr. Champion said, it was about 9 different individuals, basically, that you were able to test from those swabs.
Yes, we had about 9 individual reference samples, correct.
Okay. And the two different types of testing that were done, let's say first the mixed autosomal DNA, well, mixed autosomal STR DNA, that would be a bit more particular and precise as to determining whether or not a person's DNA was on something, correct?
So autosomal DNA testing is statistically stronger than Y chromosome analysis because of the fact that all males in the same paternal line share that Y chromosome profile, whereas each person's individual autosomal profile is considered to be more or less unique to them, with the exception of identical twins. So statistically, autosomal testing is statistically stronger.
Okay, so in this instance, the testing that was done that statistically would be stronger and more accurate, Quinton Tellis was excluded from that.
He was excluded, but I want to just back up to the use of the word accurate. Just because it's more statistically significant doesn't mean that Y chromosome testing is, less accurate or more prone to inaccuracies or mistakes. So results that are generated through Y chromosome testing are accurate. They just are not statistically as strong.
Okay, so let me ask again then. On the first type of testing, the mixed autosomal STR DNA, on that particular type, because the autosomal or our autosomes are more particular to us as individuals, statistically, that type of testing is stronger.
Yes, it is statistically stronger.
Okay, and in this particular testing, Quinton Tellis was excluded.
Correct.
Okay. And I noticed that if you will go to page 3. It talks about that second testing. You agree with that?
I'm sorry, I'm not sure I'm following your question.
I'm sorry, you see number 2 on there where it talks about a mixed autosomal
Yes.
STR, the testing that we're talking about now?
Yes.
Okay, it talks about it consisting of at least 4 individuals,
Correct.
right? Because that's what you received after your testing.
That's correct.
Okay, and then it goes on to listing the persons who were excluded.
That's right.
Okay, Derek Holmes, Jerry Lee King, it says Lakeisha Myers, George Mister, Roscoe Spites, Anna King, and Mary Tyner are excluded as potential contributors to this mixed DNA profile, correct?
Correct,
Okay.
yes.
It does not say on there that Quinton Tellis was excluded.
Correct. That was discovered afterwards through another review that his name was left off that list of excluded individuals.
Okay. So that is incorrect as far as how it's listed, but it has come to your realization that he was indeed excluded.
That's correct, yes. It was in our case notes. His name was left off the list of excluded individuals on the report.
And so as far as we know, there has been no person identified for the mixed autosomal testing.
The only one that was not excluded was Jessica Chambers, of the
Okay.
people that we tested.
Yes. Okay, and then moving to the second type of testing, not as strong, but tests for specifically the Y chromosome, which is male.
Correct.
Okay, and that would be number 4. Again, it's the same profile that says that consisting of at least 4 male individuals, correct?
Yes.
Okay. And it says that, you said that, I think you said, I can't get my words out, significantly less female was present. Is that what you testified to?
Well, no, on the autosomal test, the first mixture that we just talked about, one of the 16 areas that we target is the sex chromosomes, X and Y. to give us an indication of if there's male or female or both. And both an X chromosome and a Y chromosome were seen in that autosomal testing, but the Y chromosome was significantly less, indicating that there was less male DNA than female. And those situations are kind of ideal for attempting Y chromosome analysis, because it could indicate that a lot of that female DNA may be masking some of that small amount of male DNA that could be there. So Y chromosome analysis was then performed on those keys.
Okay. Do you typically, if you start out where in the mixed autosomal testing, if you start out and a person has been excluded, do you continue on with the second type of testing, the mixed Y-STR testing?
We do, depending on the nature of the sample itself. Again, because we saw just a very small Y chromosome peak on that mixture, it indicated that the amounts of male and female DNA were not even. And it could be a matter of some small amounts of male DNA potentially being masked by that higher level of female DNA. So in that situation, it is, again, a kind of a prime candidate for Y chromosome analysis. If we had a mixture of individuals where the X and Y peak were even, typically Y chromosome analysis may offer no advantage in that type of scenario. So Y chromosome analysis may not be done in that case. But this case where the Y chromosome in the autosomal testing was so significantly less than the X chromosome testing, it is a good candidate for that Y chromosome analysis.
Okay. So even though, I'm not sure if I'm asking the same thing again, even though in the first testing, which appears to be statistically stronger, that Quinton Tellus was excluded completely, there was an additional testing which would target for the Y chromosome. I guess I'm not understanding why was there additional testing when he had been excluded?
I'll give you a good case example that I use a lot when describing Y chromosome analysis. And this is an item of evidence completely unrelated to this case, but it's a good kind of teaching tool. So an alleged weapon in a murder case was a knife. The victim was female, and the supposed murder weapon was covered in blood, the blade, and a lot of the handle. So typically in a case like that, I will try and process the blood to get the DNA from the blood, and also try and process the handle to see if there's any indication of whose DNA may have been on the handle. Well, because there was a significant amount of blood on the handle, when processing that handle, only female DNA was seen doing the autosomal DNA analysis. Y chromosome analysis is done afterwards to essentially ignore all of that female DNA because there's a high amount of it from the blood on that handle. Y chromosome analysis is done to hopefully pick up on any male DNA that may have been overshadowed by that overwhelming amount of female DNA in the blood. So it's not uncommon to follow autosomal testing with Y chromosome analysis, especially when a female victim or a high level of female DNA is seen in initial autosomal testing.
Okay. And in this instance, though, there were actually 4 male individuals that were taken from, or at least listed in the profile.
That's correct. So the Y chromosome analysis was done, and it did still indicate multiple males. At least 4 males were in the Y chromosome testing.
Okay. And then the statement in 4 where he cannot be excluded as a potential contributor, that does not necessarily mean that his DNA was on the keys. It just means that he cannot be excluded as a potential contributor. Am I saying that properly?
That's right. I can't ever say that it is his DNA. I can say only that he cannot be excluded as a potential contributor because his DNA is seen within that mixture. His genetic markers, his Y chromosome markers, are seen within that Y chromosome mixture.
But you can't say that it's necessarily his DNA because of those markers, those 16 markers that are targeted, he can't be, you can't say that it's his DNA.
That's correct. I can't say it's his, only that he cannot be excluded.
But we can say that he was excluded in the stronger testing.
In the autosomal testing, correct, he was excluded.
Course indulgence, just a moment. I would tend to finish, Your Honor.
All right, redirect?
Yes. Right, just so the jury understands, the autosomal is going to be more accurate or strong when you have an individual profile that you can pull. Is that correct?
So again, I don't like the word accurate, but
All
so
right,
I
whatever
think.
word you choose to use.
Yes, so I think what you're trying to ask is if there's a single source profile obtained from an item of evidence, if it's, in other words, not a mixture, if it's one person's individual profile obtained from an item of evidence, that can be exactly matched to someone's DNA reference profile, the statistics are stronger for that type of a match. You can see an exact match between the evidence and that person's individual profile. And again, those statistics, excuse me, I mentioned earlier, the frequency of that profile is less than 1 in 999 trillion. With mixtures, it's a little bit different. We are, instead of seeing an exact match, we are looking for that person's reference DNA markers within the mixture. So the statistics that we have to use when handling that are different. Exclusion probabilities have to be calculated, and it is not quite as statistically significant as this 1 in 999 trillion match.
Okay. And then when you can't look at that, but you see a Y chromosome, does that tell you that there is male DNA in that mixture?
Yes, the presence of a Y chromosome peak, however small it may be, does indicate there's male DNA within that mixture.
Okay, and what you were talking about a minute ago, if I understand in this particular case, you said the female X chromosome was masking the Y chromosome. Is that correct?
Well, the X chromosome was significantly higher than the Y chromosome, which means the level of female DNA or X chromosome DNA in that mixture is significantly higher. And there's the potential for small amounts of male DNA to be masked or hidden by higher levels of someone else's DNA.
So if I'm just use this as an example, and I'm using the example you used a moment ago with the blood in your case, which you knew was from a female victim, on top of the handle. And so what you did was, through your testing, was to eliminate this, to look and see what was underneath it. Is that basically correct?
Well, yes. So when I swab the handle, of course, I'm going to swab up some of that blood as well. So any cells that may have been on the handle are swabbed up, as well as that high level of blood. So that high level of female blood, in that particular case, masked the very tiny amount of male contact DNA that was also on the handle. And so, again, that was a prime candidate or a very good use for Y chromosome analysis. So it's essentially ignoring all that female DNA because it's only targeting Y chromosome DNA, which only males have.
So the testing is specific to male chromosomes. Is that correct?
That's correct.
Okay. And once you realized in this case that you had a large amount of X chromosomes, is that the reason you went to look for the Y chromosomes?
Exactly, because the Y component was significantly smaller It's again, kind of a prime candidate situation for that Y chromosome analysis, to help ignore all that higher level of female DNA and zero in on that Y chromosome DNA.
Okay. And if I understand your testimony and your report, Quinton Tellis' Y chromosome are or is on those keys.
He cannot be excluded as a contributor to that Y chromosome mixture.
As well as the male, I can't say the males in his side of the family. Is that correct?
Paternally related
Paternally,
males,
thank you.
yes.
Nothing further, Your Honor. She may be finally released.
All right. Thank you for coming. You're finally excused. You may remain in the courtroom if you wish, or you may leave. Thank you. May I call your next witness?
Judge, we got one more matter here, and then we need to approach the bench.
All right. A little early for our morning recess, but I've been advised that there's some matters I'm gonna have to take up outside of your presence, some matters that I'll have to deal with, some matters of law. And also there's, I think, one of the next witnesses, we're going to have some equipment set up here for you. So I'm gonna go on and put you in recess now to your jury room, and I will send for you when we're ready. Thank you. We'll be in recess for 15 or so minutes.
Have a seat.